Yep.
5412, when you're talking about waveforms, I mean,
Yeah.
what does that mean specifically?
The shape of the current or the shape of the voltage you would apply, and how, and in particular with the current, how much energy would be in that current pulse. So if we're doing destructive testing, like we're applying, putting a direct strike on an aircraft wingtip or something like that.
Okay.
The 5412 would tell you how much current, the peak current, and the amount of energy that would be in that current pulse. There's actually either 3 or 4 pulses that get applied during a single lightning test. It all happens at one time, even though there's 3 or 4 different, well, there's usually just 3 currents that are being applied simultaneously, and then there's another one added at the end. But there's that defines the either the average current, the amount of coulombs, which is a measure of current over time, or the action integral, which is a measure of basically instantaneous energy or power that's dissipated. Those things define are in 5412 so that we have some consistency in the testing. And it's also in today's world, in the analytical side, in the modeling, you want to have defined waveforms, current waveforms and voltage waveforms that you're applying either in a test environment or in a computational environment, because you're really hoping, the goal is that you can take your aircraft part or take your aircraft design to any of the different places that do testing around the world or analysis around the world and get the same result out.
Okay.
And that's what drives the 5412, and that you're applying the right amount of energy, and that the energy is representative of what we have either measured, and mostly measured on the ground, or is representative of something that's going to happen in flight. Right? So you don't want to apply too little, but you also don't want to apply way more than what would actually occur, because you're going to put protection on the aircraft, which you don't need.